Okay, we're going to go a little deeper into the AC system. There's a fair amount of electrical stuff on here, and so the ones of you guys that are in electrical one are going to benefit from this, okay? And so some of it's refrigerant related, some of it's electrical related. We're going to plow right into this thing, and we're going to try to be ready, done before lunchtime. And so what we're looking at here, we talked a little bit about some of this last time. This is a tank of 134A. One of y'all just handled a tank like this morning. Now this right here, this little tank right here, they sell these in little small tanks. This is a, there's a smaller tank they sell from this. This stuff right here, 10 pounds of it costs $800. That's a new refrigerant, okay? So don't vent refrigerant to the atmosphere. Our 134A refrigerant boils at minus 15.34, our 34 YFO, which is this one here, boils at minus 22. When liquid boils, it absorbs heat. And since refrigerant boils at below zero, it causes the evaporator to get really cold, and we got to take advantage of that to make us cool. All right, so here's your fixed orifice system. That's what a fixed orifice looks like. Anytime you're working on one of these and there's been a problem with the compressor, or there's been something going on where you've got some trash in there, like for sometimes the desiccant bag in this thing here will come apart. But you need to pull that orifice tube out of there, and it'll typically be a place right there where you can, on most of them, not on all of them, but on most of them, you like to have a couple of fittings you can take loose right there, and you can pull this orifice out of there. You can typically get a little skinny pair of needle nose and pull them in and jerk it right out of there. These don't cost but a couple of dollars, but they are color coded, and so you need to figure out what color it is and put another one back in there the same color. So they got different orifices in there. Fixed orifice system will have an accumulator, that big can. Some of you have already seen that. This thing right here, okay, that's an accumulator. See how big it is. Okay, so your high side flow goes through the condenser, goes back into the evaporator through the orifice. All right, we'll talk about our liquid and our gas and all that in a minute. And there's where the accumulator is mounted. There's the accumulators in the suction line before you get to the compressor. All right, now on this one here, the receiver dryer is basically on the high side line before you get to the expansion valve. So if you've got an expansion valve, you'll have a receiver dryer. It's skinnier than that, and there's some laying right up there. See that skinny aluminum thing laying up there behind that fuel composition sensor? Stand up. Stand up. Right here. Right here. Right there. See where I'm pointing? Right there. Yeah, duh. Okay, give that to them, pass it around. You can see the difference between that and this other thing. That's a receiver dryer. Sometimes the receiver dryer is built into the side of the condenser. Thermal expansion valve will have a receiver dryer. So if it's got a little skinny can like that and not the big one like this one, then you know it's going to have an expansion valve. And the expansion valve can look like that or like that primarily. This one right here is going to go right at the firewall where it goes in there. Okay, now this right here, we're going to take a closer look at this. It's a variable orifice system. The orifice is the place where the high pressure liquid becomes low pressure liquid. And so you basically, you're going to have your liquid line come in here, and it's going to go through here, and it's going to turn into low pressure liquid. And as it does, it evaporates, and the air blowing through there picks up that, gives up its heat. This is evaporating coolant. But this little bulb right here is going to sense the temperature of that line. If it gets too cold, it's going to change the size of that orifice so that you don't have, so it doesn't get as cold. And it's made so that it won't freeze the evaporator up. If the evaporator freezes up, turns into a block of ice, you got no air. You got me? Because this is condensing. It's like a glass of tea all the time. You might have even seen these things here, all sweaty and cold and dripping water. And also you got that water dripping out on the pavement and everything too. Now look at this, high pressure vapor is pink. So watch this line right here. Everybody pay close attention to this because I'm going to be drawing this on the board and I'm going to let you explain draw it. See, it's right here, your discharge line. Coming from your air conditioner compressor, that's your discharge line going into the condenser. This is in front of the radiator. Coming out of here on this TXV system, you basically got this receiver dryer, and then you follow all the way up here and you go in here and it makes a circle. Now you got a fan blowing through this, you got a fan blowing through that, or air going down the road. Incidentally, there was a Jeep that came in here one time, an 05 Grand Cherokee that lost all its juice on the way from Tennessee. It picked up a rock and knocked a hole in that thing. And it's really something how they put that thing so exposed down there where a rock can hit it. It's surprising more of them don't leak than what they do. The receiver dryer contains desiccant, which is the small amounts of moisture from the refrigerant and high pressure dryer. You've seen them little packs that you have in bottles of pills and stuff that say don't eat? That's desiccant. It absorbs moisture. Now this right here is a system with the orifice. See, that's the orifice up there. This is the accumulator, and basically it contains a desiccant bag too. You can see the desiccant bag here, and some desiccant is leaked out of it. Right? You see that? That's a pretty cool little, cutaway there. You might notice that the refrigerant that's coming out of here is still going to have some liquid in it. We don't want any of that liquid making it into the compressor, so what we're going to do is let that liquid fall down here. There's a little tiny hole right there, and whenever the vapor from up here is making its way through here going to the compressor, which is vapor is going to be what's up in the top, the liquid and the oil is going to be down here at the bottom. There's going to be some oil that's going to be pulled through that little hole. There's a screen right there too, and it's going to oil the compressor, just like the fuel oil makes a chainsaw. The chainsaw oil, you got to mix gas and oil so that so that the mix can go through the crankcase and lubricate the crankshaft, because it doesn't have an oil pump, and it doesn't even have splash oil like a lawnmower. And also it'll run upside down and all other kind of thing. Okay, so let me go back and forth between these two. See the difference in those two systems? See that? You see the expansion valve, right? What takes the place of the expansion valve? The orifice. The orifice is fixed. Now there are some orifices like this that are variable orifices, but that's sort of not very common, and I actually saw a diagram of one of them operating one time on a PowerPoint thing at the Max convention years ago, but I don't know if I've ever encountered one of those, but it's about the same size as that, and it's a variable orifice. All right, now this is kind of what this thing looks like on the inside. All that can come here, this is going out here to the compressor, and this is coming in from the evaporator. Some of that's going to be liquid. So you got liquid in there. So you got oil and you got refrigerant mixed in there, kind of like a Dr. Pepper, and it's probably going to be about that full. All right, and on that right there, if you look at this one here, you can see that little screen. You see the little screen? And there's a little hole in the bottom of that tube. So that's how that thing's going to pick up that oil. Whenever it's pulling this vapor through here, so that oil's going to mist its way in there, and you're going to have the oil. But if you have oil that doesn't mix with the refrigerant you're using, you're going to burn something up. Because 134 and 12 and other refrigerants they take, you got to make sure the oil you're using is compatible with the refrigerant you're using. That's really important. TXV system high side. Now, some of them have a sight glass here. That's kind of useless. We don't use that anymore much. It's like an R12 thing. But you basically, what you got right here is your inlet. Basically is all that refrigerant's got to go through this desiccant, these filter pads, and be picked up to go out to the expansion valve. So this is not only the moisture taken out, but every other little anything that could get out of there is going to be kept from going to the expansion valve, because those things like to stop up. Here's a little rule of thumb: if your high side, if you got a full refrigerant charge, and your high side and your low side are both low, that means your expansion valve clogged up. You got that? Just kind of keep that in mind. Okay, rear air on vans will have a separate evaporator and heater core will typically outfitted with a TXV, even if the front air has a big surface. So you'll have an evaporator back here in the back on vans that have auxiliary air, but they'll typically always have an expansion valve back there. And the front system will use an orifice, but they're all using the same compressor. And they just got more refrigerant charge. And the refrigerant flows through these. Here's a condenser. The condenser's a big thing. And then this right here's your suction line. And that's going into the evaporator, and then basically, the liquid line goes into the evaporator. I put those words on there wrong, I screwed that up. Liquid line goes into the evaporator, suction line comes out of the evaporator, but they don't even have the suction line pictured here. You know what I'm saying? But anyway, here's the discharge line going back into the condenser. Remember, the line between the compressor and the condenser is the discharge line. You got that? The line between the condenser and the evaporator is the liquid line. So you're going to have a low pressure liquid until it hits the orifice. High pressure liquid until it hits the orifice, turns into low pressure liquid, evaporates, absorbs the heat, and then it's going to keep on absorbing heat. And remember, if your suction line is cold all the way to the compressor, that means you got a good charge on that thing typically. Your compressor's got to be good and strong. If the compressor is weak, you may look at readings on there where your low side, your high side, the compressor is running, high side is not very high, low side is not very low, you got a weak compressor on that typically. Now some of them have got what they call a subcooler on it, and this receiver dryer will be actually built onto the side of the condenser. And this right here, you got your inlet hot gas refrigerant going through here, and you might notice that the dryer is over here. Okay, and this liquid refrigerant is going to be a little modulator, they call it up there, and this gas goes through here, and the subcooler cools the refrigerant after after it's lost all of this heat through the condenser, it's going to cool off a little more. So what you got coming out of here is not only liquid refrigerant, but it's liquid refrigerant that's cooler. Now this looks just like a condenser. And on these, you'll have to screw a little cap out of the bottom of that, and the desiccant is a long bag that goes in there. All right, so just keep that in mind. You may have to do that. The Sonata is like that. It's basically got this built on the side of that. Sometimes the receiver dryer is going to be nothing but a bag you change. All right. Now that right there, I just drew a picture of that to that so you can see what we're doing now. Electrical stuff, fans, clutches, and switches. This right here where you put, this thing's only got just a few ohms, like 2 or 3 or 4 ohms. And whenever and it pulls less than 10 amps typically. And whenever you pull whenever you put power and ground there, this turns into a super strong magnet. It pulls that against that and makes the compressor innards spin because that pulley's always spinning and there's a bearing in there. And then here you get your switches, you get your condenser fan, you get your blower and resistor. Now a lot of the times, this resistor blower, if the blower's not working, you're going to find the connectors that are burned because there's a lot of current flowing through there. And I've got 2 or 3 resistors out here that I saved where it cooked the connector here and burned it all up. And you basically would get you another pigtail that you can buy that and that resistor. And you know the blower motor that won't typically have a problem unless the connector plugging into the blower motor is burned up too. So look for that. Always look at those connectors, see if they're burned. Then you got your relays and your controls over here, you know, where you turn the knobs. So we have to change these fairly regularly. And this little control box is basically talking about that in a minute. It's a simple schematic. Pay attention, electrical people. This is what we're going here. We got a circuit right here. We're going to the on switch, high pressure switch. You notice this is normally closed. Low pressure switch is normally open. Then your AC clutch. If you have low pressure, your AC is not going to engage on a system like this. In other words, this is not even going to run. Okay, there's your AC clutch I drew like that. So when your pressure gets too high, this one opens. So if your pressure gets too high, the compressor kicks off. If the pressure gets too low, the compressor kicks off. Some of them will have a 3-wire sensor here. There's actually a transducer. All right, come on. All right, now this is more modern wiring right here. What you got right here is a PCM or amplifier, which is going to be taking an information. Sometimes you'll have another little box that's talking to the PCM. Okay, so your high pressure switch, you might notice you turn this on. Your high pressure switch is basically sending a signal to the computer, and the low pressure switch is too. So it's paying attention to both of those, and it decides whether to operate the relay to turn on the compressor clutch. You see how that works? All right, now usually that's the way this is fixed. The controller is actually a middleman, and it's reading the pressures and doing the work for you. All you're doing is turning on the AC. All right, now this right here is a Pcm Ac Input on a 2000 F-150. You notice the switch directly feeds power PCM 41. See that? These right here are actually going to the PCM. It's paying attention to both of those. And then it's going to decide what to do with this relay. You see, so that's what we got right here. Now look at this AC clutch diode. A diode is a one-way valve for electrical systems. If you got a diode, it won't let power go but one way. All right, and so if you put that power right here, watch this, watch this power do. The power cannot go that way. It goes here, goes through the clutch to ground. But when you disengage the clutch, that collapsing magnetic field is going to sweep across all those windings and make about a 400 volt spike. Now that 400 volt spike, if you don't have this diode here to let it chase its tail and go away, then that 400 volt spike is going to come screaming back through there, and it's going to find something to screw up. And I worked on this Daleville Cablevision truck where they had a AC type clutch pulling a PTO for the hydraulics for their bucket truck, and it ate a radio a month. It was a brand new truck for about 3 months, and finally they took it from the new car people. They kept putting the radio in there. It was just AM FM radio, but it would fry the radio. And I got my scope and I put on it, and I started turning stuff off and on. And when I turned that PTO off and on, I saw a 400 volt spike that went screaming into my radio circuit. I mean, it was like off the top of the screen. I said, oh my goodness, look at that. And what happened was they put this clutch on there. It was a clutch like an AC clutch to turn that PTO, but they didn't install a diode. And so it was able to make its way back through there and find its way to the radio. And you take the radio and you do this a few times with it, with 400 volts, it's finally going to go, ugh, and it's not going to do anything. And that's what was going on with that one. All right, so, and that diode can burn out and go bad and everything else, so pay attention to that. If your AC is blowing a fuse, make sure that diode is not shorted. All right, so here's your fan control. You might notice this right here. Whenever you turn this on, you got to be able to work. Watch this. Turn this on. When you turn on your, let's say you're going to turn this on, we're going to energize the blower relay. All right, what happens to the blower relay? This clicks, the motor gets hot, right? You get power going to the motor. You might notice this is all switched on the ground side. And look at this. How does this flow? It flows through that thermal limiter. It goes all the way through all those resistors, and then it goes to ground. So that path to ground goes through all of those thermal resistors, goes to the fan, and it's going to run at the lowest speed. Now when you come up to these other ones, each time you click this to another switch position, you're taking one of the resistors out of the circuit, and the fan gets faster and faster. You see that board right over there? That's where I'll let you know, I mean the one with the fan on it, behind that other one, I'll let you guys in electrical wire that up. All right, now this is going to look familiar to you because you had this in your hand the other day. When you turn on the fan on high, it sounds like it's shaking the dash of the car, like that. When you pull the fan out, you're all going to find a bunch of crud in there like that. Rags, paper, dead rats, that kind of thing, you know what I'm saying? If it's dead rats, you know, you might want to try to get somebody else to do it for you, but they probably won't, so you're going to be stuck with the dead rat. We actually had a lady that came in here, well, she works here, and she drove all the way over there with her fan under the hood shaking, and there was 2 dead, full-grown cats down at the bottom of the radiator shroud because they were up in there when she cranked it up and busted the fan. And so we had to get the cats out of it and everything else. So anyway, so you got air control now. You got all these doors in the dash. All this stuff moves in the dash when you're turning them knobs. That's why that air changes position. These are the older kind with a vacuum, right? You got a vacuum reservoir. You got a little check valve. When that check valve goes bad and you get in it hard going up a hill, everything goes to defrost. Seen that happen? Have you ever seen one whenever you're into it hard, it goes up to defrost? Or maybe when you crank it up, it won't go anywhere but defrost? Well, if you find out you either got a busted vacuum reservoir, no vacuum coming from here, or this diaphragm, if this is bad, it'll go to defrost when you're driving up a hill. And there's your AC selector switch. Your heater core is here, blower motor's here, then inside and outside air. Then you got your normal max door, and it flips back and forth like that. The evaporator. Now watch this. What comes in here goes through here. If the heater core is isolated, then you're going to have nothing but nice cold air wherever you got it, you know, your mode going. Now you can actually move this blend door anywhere through its track and stop it somewhere. You can actually make that air still be dry because this dehumidifies it, but it's basically going to warm the air up a little bit. You know, like on a cold day where you don't want to have less moisture in the car, but you want it to be warm. So you want it to be warm and dry. Okay. Now on this one right here, they put a blend door potentiometer. Back in the day, they used to have like a 2-stage vacuum door that would try to help you with your temperature. Nowadays, even though everything else may be operated by vacuum, they'll have a blend door actuator so that little blue and red one, it's actually going to, you turn it back and forth, and that blend door can stop anywhere. So you can have a sort of a infinite variety of cool and warm. That little Ranger's got one of these on it, even though everything else on the truck's operated with vacuum. First thing we got to know, this is a funny story. When I first came here, I was teaching, and there was a guy named Jerry that was in here, and he was about 40-something years old, and he's an old country boy. And we pulled this Buick Riviera in here. We're going to check the air conditioner on it. So I'm looking under the hood, I'm watching the AC clutch. This is, Jerry, get in there and turn on the air conditioner. We're going to see if the AC clutch runs. So I'm standing there. Jerry gets out, and he's rubbing his face, you know, after 4 or 5 minutes. I guess he's going to take a 30-second job, make it last 5 minutes, you know what I'm saying? And I said, what's going on, Jerry? I don't guess I know how to turn the air conditioner on this car. And so I said, really? Seriously? Let me get in there and see what I can do with this. So I got in there and I looked at it for a little bit. I had about the same trouble he did. But what happened was, it was one of these. In the middle of it, this was an 85 Buick Riviera, and it had a little CRT screen there, and it had all of these different functions that same screen would do. And if you wanted to do radio, you'd select radio. If you wanted to do climate control, you'd select climate control, and whatever else. And see, after you get whatever you had on there, it would throw it was a touch screen. In 1985, think about that.
Crazy.
Yeah, isn't that crazy? Anyway, that was what it needed to be. But the point is, if you don't know how to turn the air conditioner on, you better find out how to turn it on before you start checking it, or you may do a bunch of work you don't need to do. And what you do on these things, you pull, some of them you pull the switch out, some of the older Mazdas and stuff. All right, The next thing we're going to do, we're working on the AC because it doesn't cool or doesn't cool it, doesn't do well, doesn't cool at all. We're going to see if this clutch kicks in and runs. That's not a very good picture of that, but there you go. May take a few seconds for the PCM to turn it on, so be patient. If it doesn't run, what are we going to do now? We're going to find the fittings. Some of them put them in a really good place, easy to get to. Some of them, there was a Jaguar we worked on, and the low side fitting was underneath the car behind the driver's wheel. The word stupid comes to mind. Why in the world would you put the thing underneath the car behind the driver's wheel? I mean, we look for that thing. We finally found it in all that. The low side port's usually on the suction line or the accumulator, and the high side port tends to be on the discharge line between the compressor and condenser. The high side is the larger port on the R134A system. All right, connect your identifier so you'll know what's in the system before you connect anything else. If it's contaminated, you use a different machine to pull it out. You see this right here? This was a vehicle we worked on. 23% R134, 76% R12. A shop that doesn't have a refrigerant identifier, it could hook up to this car and they would pull that trash into their machine and they would be spreading it around to the next 2 or 3 cars they worked on. And then the next shop that didn't have an identifier would pull that trash out and it spreads all over. You see where I'm going? You need an identifier. You need to be able to tell what's in it. Yeah, I know it's $1,000, but if you care about the cars you're working on, you're not going to do something without checking to see what's in there. You know, just like you're basically, if somebody hands you a glass of water and you don't know if it's half alcohol and half water, you know what I'm saying? All right. We take this machine right here, like we got in there. You're supposed to have a gray tank with a yellow top, like that one right there. We did this one the other day. And you plug that, I put that machine on the floor, and I hook it up to a set of gauges I got, and we pump, it recovers, and it pulls out what it's going there. That stuff has got to be captured. This particular one was 60% air when it came in here. This is the one she paid $700 to have an air conditioner compressor put on it. It wouldn't cool. I don't know why she didn't go back to the shop where she had it done. Came in here, we hooked up our refrigerant identifier first. We found 60% air, and you know, it was a horrible mix of air and refrigerant. We pulled all of that out and stuffed it in that tank over there just to be safe. And then we went ahead and sucked it down and recharged it with the right amount of refrigerant. That's all we did, and it was cool as a cucumber. The refrigerant identifier found the problem pronto. How long would we have been digging if the compressor's running and it ain't cooling and the pressures are screwy, you know what I'm saying? Now, if it doesn't run, you got to check the gas. This is the static pressures right here. I borrowed this photo from online. There you got 100 pounds and 100 pounds. Now, there is not a cut and dried set of static pressures that work. If you see 100 pounds, then at least you know there's 100 pounds of static pressure in there. But I've seen them read 100 pounds and still be low on refrigerant. So you can't go by that. However, if it's really low static pressure, it's not going to have a full charge. You see what I'm saying? So it's not a go, no-go test. It's only go, no-go if you've got no pressure or very little pressure. If you got 100 pounds of pressure, that don't mean, well, the refrigerant's okay, we're through looking. All right, so there's no reliable thing. So the switch reading, the pressure cutout switch on the ones that have one of those is less than 24 pounds. Some of them measure the temperature of the evaporator to cycle a compressor on it all too, by the way. All right, so if you pull it down to 30 inches, which 30 inches is all the vacuum you can have, if there is pressure, use it to recover the gas. You might have to run the engine on cold days and heat the engine compartment up to get all the gas out of it with an older machine like this one we got. So pay attention to how much came out and compare that to the specs and watch how much oil goes into that oil can. Put that much in there. This one lady I know had a Taurus and she kept going by the Ford place and they kept pulling the juice out and putting the right amount in there until they pulled enough oil out of there to where the compressor burned up. See, they weren't replacing the oil, they were pulling out every time they recovered it. Is what was going on there, and we wound up having that. So, if it still won't run with a full charge, we find and remove the AC relay, and we find the relay terminal feeding the AC clutch. We did this morning, didn't we? You and me and him. All right, and then if the test light lights between B plus and the clutch terminal, it's supposed to light. It should light right there. Put power there to that terminal and see if the clutch clicks. All right. You can also check AC clutch relay output with a test light if you know how. If you pull it up where you can get to that terminal that you know is going out, you can see if that relay is putting power out to the clutch. All right. Now, if no ground shows, either this coil is burned out, you got a bad ground, or you got a wiring problem. That's all there is to it. You'd be surprised how many times you're going to find a wire burnout. This lady came in here with a 2010 Altima, and she says, I went over to this place in this other town, and they shine a flashlight down in there, so we don't know what's wrong, but it'll be $1,000. I'm serious. I mean, that sounds like a comic. You know, she brought it over here. I went into that wire right there, leading down the compressor clutch, checked it for a ground. There wasn't one. Burned out clutch. So we put her a clutch and a compressor on there and all that kind of thing. See, we knew what was wrong with it. She didn't pay $1,000 either, because it was only 0.8 of an hour labor to change that compressor. There's another lady called 2 days later and said her Altima was in another shop in a different town, and they wanted $1,000 to put a compressor on it. She asked them why it was so much. They go, oh, it's 7 or 8 hours labor to put the compressor on. Well, I said, we just did one of those, and it was only 0.8 of an hour. And it ain't that hard to do, you know. So, you know, there's no use in, you know.
It'd be taxing.
I'm telling you. With a relay removed and the AC on, you ought to have 2 powers and 2 grounds. You remember that? You ought to have 2 powers and 2 grounds in that relay socket. Remember that. 2 powers and 2 grounds if the relay is being energized by the PCM. With a 2-way talking scan tool, you can tell the PCM to turn on the AC clutch relay and see what happens. Any wire can be compromised, so watch out for that. All right. If it cools fine and then it stops after you're driving a while, with it sitting there running, tap the clutch with something, and if the clutch clicks, be careful when you're tapping it, because you don't want the thing to throw the screwdriver through your throat. But you know, tap it with something, and if that clutch clicks in and then it runs until it cycles off again and then doesn't click back in when it should, like if there's power and ground going to the clutch, but it ain't clicked in, the clutch ain't burned out, the air gap may be too wide. And as these surfaces wear, you're going to have that. You're going to actually have shims in there on most of these. And you're going to take one of the shims out. You got different thicknesses of those shims, and basically you're going to set it so it's about as thick as a business card. You got me? All right. You can also use the data stream. Look for HVAC influence. This is stuck in the register on a car that we were working on. It went down to 20 degrees, and the evaporator temperature on the scan tool said 48. This and this were supposed to agree, and the evaporator was freezing up on that car. I have seen the relay be stuck. Gene Taylor had on his truck. It was killing the battery, and the AC would quit cooling after he drove about halfway to Geneva. And the problem with that was his AC clutch was all always on, and that was killing the battery, and it was making the AC freeze up. You got it? Okay, so the cutout switch was on a Dodge truck. It wouldn't open. It was stuck closed. And it just kept getting colder and colder and colder, so it made the evaporator block last. All right, now pay attention to your fuses. Pay attention to these switches. Pay attention to this. You can actually put your fingers on those switches usually when they're cycling on and off and feel them click. If you're feeling them click but other things aren't happening, you know there's an issue there. Pay attention to the pin fit on the connector. Anybody got any questions? You can actually review this from YouTube if you need to go back and look at this again, because this is a heck of a lot of concentrated stuff. There's about 4 PowerPoint presentations stacked into one here in a 30-minute session. You got it? And so there's a heck of a lot of good information in there that you can get. So everybody happy with that? What do you know, Nick? You weren't sleeping, were you?
I'm not. I wasn't sleeping.
You weren't sleeping? You look like you were pretty dozy. Is that right? What about you? Did you have your hair combed better than that when you had your picture took this morning? You should have. What about you? You learned something? A little bit. What about you? You know something now? What about? You got this? You guys got some benefit out of this because you saw this morning when I was just showing you. And it ain't complicated, is it? Wasn't that hard to do? What do you think, Glenn? Okay. What about you, Mr. Abrams?
I got some.
Yeah. Huh?
I worked on the fan with him, with the launcher.
Yep.